Year 10! Hey guys, hey everybody, how's it going? Hi Ananya, hi Tiffany, hi Ryan, hi Lynn, hi Zach, hi Atia. What up? I just did that live on YouTube. I don't know what happened there. I don't know what happened. Hey Marley. Right, I'm just gonna quickly do the register. Guys, did you see the sheet that I have created? I have created a sheet. Don't register anymore. Close that one. I'm poking around in the screen now. There we go. Cringe. That's amazing. Oh, hey helping. Hey Amadi. A sheet of our mistakes. Atia, you guys have done amazing. What are you talking about? I don't know what you're talking about. Amani's here. Zach's here. Sophia? Do I have Sophia? I thought I saw Sophia. Did I see Sophia? No, haven't got Sophia yet. Got Tiffany? I've got Tiffany. Whoop, whoop. I've got Kayla. I know that Kayla usually a bit later. There's Sophia, winner. And then I've got Mel. Audra's in. Audra's in the house. Yep. I've got Atia. I've got Ananya. Have I got Dom? Yeah, there's Dom. There's Kayla. Whoop, whoop. Kayla's in the house. Has anyone seen Lara? There's Kayla. Or Mel. There's Lara. Whoop, whoop. Then we've got Caitlin. Anyone seen Caitlin? I'm here, Mr. Duncan. Oh, that's such a sad face. Oh, don't be sad. Has anyone seen? I've got Lynn. Got Hao Ping. Yes. We're 4 people missing now, folks. 4 people missing. I'm missing Mel. I'm missing Caitlin, Ryan. Have I got Ryan? Did I see Ryan? Yeah, sorry, Ryan. You were in like way first. Sorry, Ryan. Booyah. Yeah, I did remember. I remembered eventually. Caitlin, Libby, and Mel. Those are my 2 that I'm missing. Caitlin, Libby, and Mel. I'm nearly there. Can anyone send them a message for me? That'd be amazing. Yeah, so guys, I've created a wonderful worksheet for you. Oh, look at your data. Yay. I love you guys. You guys are fab. Yeah, that looks amazing. Keep going, guys. Keep lobbing it in. That's amazing. Love it. I get so excited about when I see you guys. You guys are awesome. Oh, who's just posted the YouTube video of the watch one? I don't quite get it. Like, number one is it won't let me actually like. Oh, there's the link. What's this? Don't tell me this is me. Is this actually me? It's just me on repeat. Oh, that's funny. Okay, so we're still missing a few people. Still missing Caitlin, still missing Libby, still missing Mel. There's Caitlin, yay! Hi, Caitlin. I suddenly realized I'm looking at the wrong computer. I'm like, oh, no. There's Mel, whoop, whoop. Yeah, 1 more person to go. Libby is always a bit late, isn't she? Isn't the reacting mass worksheets out of 10? It could be, I don't know. Elijah, hey Libby. Oh, Elijah's here. One of my year 11s. That's awesome. Definitely worthwhile a visit, this Elijah. Going to be doing water crystallizations today. Definitely worthwhile. And I'll even add you to the classroom so you can have a look at the worksheet that I post for them. Right, guys, let's crack on, shall we? So today's lesson, we're going to blaze through empirical formula questions that you guys have done for me. And then we're going to move on to water crystallization, which is really exciting, apart because we're only 1 away from the end of the topic. We've got water crystallization, and then we've got excess reagent questions, which are level 9s. And then we're done. Poof. Calculations is done. God, can you believe that? I feel like it's flown by. Okay, right, let's share the screen. Let's share my screen. Oh my God, guys, before I go, look at the t-shirt. It's a mole. Oh, look at his sunglasses. And look what he's made from. Oh my God, you got to see this. Look where he is made from. It's made from loads and loads of avocados number. Oh, I'm such a nerd. I have a mole t-shirt with a mole printed in Avogadro's number. It's amazing. Love it. I love it. I'm glad you guys love it too. Avocado, I know, right? Avocado's constant. You got it. Yeah. I'm such a weirdo. Okay, let's crack on. Right, let's get on with this. Let's get on with the show. Right, by the way, before I do that, now that we're on here, timestamp. Can I ask, we are 5 minutes in. Can someone log the times of when I move on through the questions for me? That'd be super handy. Can I ask Tiffany, could you do that for me? That would be super great. Super, super great. Yay, right, we're on. Boom. We're on it. Right, let's crack on, folks. So, this was your empirical formula homework. Let's see how we get on. Benzene, ooh, what a lovely opportunity to have an A-level name appear. Benzene's kind of cool. Benzene has the formula C6H6. Just to show you what it looks like this. It's just a really cool substance. I do love whenever benzene makes an appearance. It's really cool. Does anyone, by the way, benzene is a common name. Benzene is a common name. The actual name, for those people who are interested, is cyclohexa. Now that's the weird one. The A comes in because it's a tri suffix. Cyclohexa. Then you have to number it in a circle all the way around. And it's 1, 3, 5, because you have to count over a double bond. So it starts at 1, then the next one's at 3, the next one's at 5. Cyclohexa 1, 3, 5 triene. That is straight out of A2 chemistry. It's really cool. And I know that there were people in this room who were going, yeah, okay, I could do that. We can build these. Yeah, it's just standard organic. Just takes a bit of practice. So we've got benzene is C6H6. Its empirical formula is CH. Explain what each of these formulas tells us about benzene. So guys, I loved this question. It's one of my favorites because this is like absolutely typical EdXL. It is asking you for the definition of empirical and molecular in a really stupid way. Sounds like EdXL, right? I don't think EdXL are going to like me very much. Suddenly realize I'm live on YouTube and I'm totally dissing an exam board. Probably not the best idea. So molecular. So, there we go. Molecular C6H6 tells us the actual number of atoms of each element in benzene. It's nice to put it into a context. It's lovely. Then the next one, empirical CH tells us the simplest whole number ratio. Sorry, I'm sorry, I forgot. Can we say actual ratio? Yes. Is it? Yeah, sure. I prefer number. I'll definitely give you it. You can definitely have it, Mel. Just remember that in the future, put the actual number. Simplest whole number ratio of atoms simplest whole number ratio of atoms of each element in benzene. Love it. You'd usually end that with in a compound, but in this case, we're in a setting of benzene, so that's kind of cool. I really like that one. By the way, just to tell you, that there, whoa, my laptop's having a little bit of a hissy fit. Don't know what it's doing. It's going mad. Oh, that's strange. Oh, it's decided to close on me. It didn't like that. My laptop just had a little bit of a Barney. I can't remember what I was talking about now. I was going to say something really cool, and I've forgotten. Oh, no. What was I saying? I can't remember. My laptop freaked me out. Whole number of elements in benzene. Oh no, it's gone. It's gone. It's gone. Can you guys still hear me okay? Can someone just quickly post on the chat? I'm just worried that my laptop's having a bit of a Barney. And I'm worried it's cut you off or something. Can everyone still hear me okay? Yes, cool. Okay, empirical formula of sodium chloride is NaCl. It does not have a molecular formula. Explain why sodium chloride does not have a molecular formula. Because it's ionic. Because it is ionic and does not form molecules. That was hard. That's really tricky, that. It's actually the RFM, the relative formula mass. Oh, my laptop is having a proper little bit of a Barney on me here, folks. I don't know why either. There we go. It's back. That's strange. Anyway, because it's ionic and does not form molecules. That there is the RFM, the relative form. Oh, it's actually a repeating unit. Cool. Thanks, guys. Oh, helping. You're a ledge. Love your little hand sign there. Right. The following ratios are taken from experimental data. Right. The simplest whole number ratios. Right. So I covered this right at the end, folks, of my last lesson. Right at the end. I really hope I did anyway. Because what we realized is if you get a decimal, you can't just round it. You have to multiply it to make the fraction disappear. So this one's going to be times 2. So that's a ratio of actually 5 to 2. Did I cover this in my webinar? I'm really worried that I didn't. Did I cover this? I think I did, but I'm not entirely sure. It was right at the end. No. Oh no, you guys are going to have rounded them, aren't you? This is totally my fault. Right. I need to talk you through this, folks. So, okay. So really quickly, I don't think so. Okay, guys, I need to fix a little bit. Do you remember when we had our question? This is where I need to, the problem is I need questions. The problem is I made up a question and it was all wrong. Do you remember? It was an absolute fiasco. Yeah, let's say, oh, come on. I need to come up with a really good example here. Oh, hang on a minute. I can. I've got a question. Right, I need to fix this, folks, and then you don't need to include these in your score. Yeah. In fact, you can do them all whilst we do them together, but I'll fix this. Question. Compound X contains aluminium, because this is how it would be in an exam, aluminium and oxygen at, let's go, oh, this is going to be a nightmare. Oh, no, I'm going to make a mess of this again, folks. Oh, trying to do like crazy head maths. Okay. I've got to keep a number in my head and I can't do it. Right, containing 52.9% and this is going to do the same thing again. The thing problem is I do head maths and I make a mess of it. And 47.1% respectively. So just to quickly explain, I feel like I am definitely teaching English as well at times. But the word respectively means that it's in the same order. So the aluminium was the first in the list here. So aluminium's number will be 59. And then the oxygen is the second in the line. Yeah. So, and then it's going to say calculate the empirical formulae. And what you will do is you'll go aluminium and oxygen, as I taught you. You put in the percentages, 52.9 and 47.1. Change their signs to percent to mass, mass to moles, divide the smallest. Yeah, by the smallest. Right. So over 27 over 16, right? 52.9 divided by 27, which is the relative atomic mass of aluminium, and that's 1.96, which is 2. And then we've got 47.1 divided by 16 gives me, that didn't work. This is really irritating. Right. Now I've got to come up with another question that actually does what I wanted it to do. Right. We're going to have one that appears. So anyway, let me just quickly say, if these numbers here, if these numbers at the end come out as decimal points, and I mean not like that, not like 9.4, that's like just experimental error. Yeah, I'm talking about if you got oh, did I actually not follow my own rules there? Guys, hang on a second, I missed a rule. I got to moles and I've stopped. I didn't follow it through. I'm not doing this. Has been a bad day for me. Divide them all by the smallest. Divide them all by the smallest. So let's now see if I can move all of this stuff. Yeah, up 1. Right. So that's going to be 1, and 2.94 divided by 1.96 gives me 1.5. Right. That's what I wanted. Right. So lots of people have a habit of doing this. But you can't do that. What you have to do is you multiply it by a factor of 2 because it's a half, and you'll make it into a whole. So that one's times 2, which is going to therefore give Al2O3. So you have to do this multiplying trick. So let's look at this one. So this one had a half. Yeah, let's see if I can zoom in a bit further. This one here had a half. So I had to double it to make it whole. So I got a ratio of 5 to 2. And if I double one thing, I double the others. Those are the same numbers as question 4C. Really? Okay, I'll come back to that in a minute. I didn't mean to do that. This one's a third, guys. Look at this one. That one there is I shouldn't do that. This one here is a third. So I'm going to multiply this one by 3. I'm just going to shrink my pen a minute. Multiply that by 3. 1.33 times 3 gives me 4, right? That's going to become 4 to 3 is the real answer. Next one, that's 2/3. So I'm going to that was 1/3. That was the same as 1 over 3. That 0.67 is the same as 2 over 3. Times it by the denominator. We'll make it whole. Yeah, times it by 3 again. Times that by 3. And I get 3 and 2.67 times 3. And I get a whole number of 8. Yes? Next, that's a half. They're being sneaky. That's a half, folks. So times that one by 2. Yeah? That's going to give me 3 and 2. Yeah? Next, there's my 2/3 again. Yeah, there's my 2/3 again. Multiply by the denominator. Yeah, so I'm going to times that by 3, which is going to give me, again, 1.68 times by 3 gives me 5. I'm doing it on a calculator. I'm not trusting myself because I'll make errors. Yeah, the next one is a half. Yeah, it's not exactly a half, but they never will be. These maths never will. They always fluctuate ever so slightly due to rounding errors and whatnot. Yeah, times that by 2. I'm going to get 2 and 5. This one, that's 2/3 again, multiplied by the denominator, multiplied by 3. Yeah, so that's going to be 1.65 times 3 gives me 5. 5 to 3 again. Notice it's the same, those two have the same ones, but they're slightly different, but you're doing the same process. Now that's interesting. That's 3/4. Multiply it by the denominator. Yeah. Multiply by the denominator, so multiply by 4. Oh, my pen seems to be, my laptop needs probably restarting. Multiply that by 4. So 1.74 times by 4 is going to make it a whole number. That makes it 7. 7 to 4. That's the final answer. So I'll make sure, guys, you can disregard, since I hadn't covered it, you can disregard that number that question from your homework. I hadn't finished, and there's always chances that I'll always forget certain bits of chemistry. It's part and parcel. It always comes out in the wash, but you know, worth talking that through and having that fixed. Okay, so now we're on to our normal numbers, our normal questions. Work out the empirical. Right, so we've got nitrogen and hydrogen, 82.4% change to grams, 17.6% change to grams, over 14, the relative atomic mass of nitrogen, over 1, the relative atomic mass for hydrogen, that's just 17.6, that's easy. 82.4 divided by 14. Now this time, Mr. Duncan, do not forget, divide by the smallest. Yeah, there we go, divide by 5.89. I'm going to get 1, and then I'm going to get 17.6 divided by 5.89, and I get 3. It's actually, the actual answer is 2.98. It's actually 99. And then over here, I'm going to write NH3. And I wonder, year 10, can everybody please on the chat, who's first? Name it. Whoop, whoop. Name it, name it. Mm-hmm. Next. Who's going to be first in? Kaylin's first in. Dominic right behind her. Lynn's in second place. Mel's in fourth place. Coming up in fourth. Coming up in fourth is Lynn. Oh, Helping's coming up in fifth. Fifth. Coming in fifth is Helping. Hey, and Anya's in 6. Did you round up for question 3B? 3B. Did I round up? No, not at all. 3B was a third, Ananya. That was a third. So you multiply by the denominator. Or did you mean 4B? No, I haven't done 4B yet. I can't believe this. What are you talking about, Atia? I don't know what you're talking about. So what are you talking about, lads? I know, gone scouse. Okay, next question. Carbon and hydrogen. We've got 1.24. They've already done it for me. Oh, isn't that nice of them? This is very common, folks. They just skip. They do a step. I can't believe this. I did not win. Right, already in grams. So they've skipped this over 12, over 1, 0.26. Yeah, they've already done it for us. 1.24 divided by 12 gives me 0.103. Divide them all by the smallest. 103 is going to give me 1. And 2.6 divided by, no, 0.26 divided by 0.103. Oh, look at that. That's what I wanted. It's what I wanted. It's 2.5. It's 2.5. It's actually 2.52. But remember, you'd never round it. Yeah, we never round. We multiply that by 2 because that's a half. And then we multiply by the denominator. Yeah? So multiply that by 2. And I get a final answer of C2H5. Cool. Winner. Next, aluminium. Helping. There it is. There it is. Aluminium, 52.9% change to grams. Oxygen, 47.1% change to grams. Over 27, over 16. 52.9 divided by 27. Boom. 1.96. 47.1 divided by 16 gives me 2.2. I don't know why my pen is hiccuping, but it is. My laptop's doing something very odd today. Ooh, look at that. Uh-oh. I think it must be my pen. It must be my pen. I think I need to replace the battery in my pen again. Oh no. And now, oh, my pen's died entirely. I will replace the battery. The battery. Let's try that. It's gone green. Oh, no. I think it's my computer. My computer's doing something odd here, folks. Oh, no. I think this is, once again, I'm just going to close that down. I'm going to close down my snip as well. Oh, my laptop's having a fit. Oh, is the battery on full? No, let's crank it up. Let's crank you up. There we go. I bet that now works. Nope. Oh, no. Stupid computer. No, I'm closing. No, I can't close all of you guys down, but I can close loads of other people and close all of these guys down. Right. Suddenly realized that I got everyone in the classroom, didn't I? That was awesome. Winner. Going back to this. I'm sorry about this, folks. I'll be back in. Hang on. It's gonna be fixed again now. I know. Loading, right? I know. Ooh. I have no idea what my computer is doing. Oh no. It is my new one actually, yeah. Oh no. I think it's actually just flat out struggling with something and I don't know what. It won't even let me select my pen properly. Oh no. Frustrating. Hate it when it doesn't do what I wanted to do. Right, guys. Add it back to stream. Right, guys. I'm going to quickly pause the video, restart my computer. I'll be back. Okay? Okay. And then I'll join.